All right, welcome to Excel. I've got Crystalball open. The way you want to do this is install Crystalball, open it from from the Windows menu, and when you do, Excel opens up. But notice that instead of just having your normal tabs on Excel, you've got a new tab called Crystalball. But the first step in using Crystalball is building our model. And remember that the problem here is that we want to estimate how much it's going to cost to work with this neighborhood kid to complete my yard work in a typical week. So what we want to do is we want to try to build a model that will help me better understand what those costs are likely to be. So I'm looking at the problem, the prototype 11 write-up on Sakai, and I'm going to start laying out the information that I see in there. So the first thing that I'm told is that if I hire this, well, not even to talk about the kid first, how many tasks are there? Well, I'm guessing that there's about 20 different tasks that might need to be done on any given week, but not all of them need to be done every week. So the number of tasks that need to be completed is the first input parameter that I want to create. So I've created that, the name for it, and let's say I'm told that on average that this is 12. I'm going to make a note over here though, because I have some information about likely variation in that. So what I'm told in the prototype is that this might vary between 5 and 20 each week. So I'm going to make a note here. Might vary between 5 and 20. This is just a note. I find it very helpful when I read a problem description to start parsing it in Excel, writing notes from it in Excel so I can help understand really all the information that I'm given. The next sentence tells me, so the neighborhood kid will work every weekend and one weekday afternoon per week. On a weekday, he may complete between 1 and 6 tasks. That's information. So I'm going to write in number of tasks completed on weekday, the weekday that they work. Well, I don't know what that is. It's something between 1 and 6. I'll just guess that it's 3 for now, because whenever we build our base case model, we want to put a best guess in there. I'll say might vary between 1 and 6. Okay, the next input parameter that I'm told about in the prototype it says on a weekend, on any weekend, he may complete between 2 and 12 tasks. So I'll say number of tasks completed on a week end. And it's something between 2 and 12. The average is 7. I'll put that in there. Make a note. Might vary between 2 and 12. Okay. Let me keep reading in the prototype. So any unfinished tasks will get completed first thing the following week, so they're likely to get done pretty quickly. And because I'm extremely embarrassed when my yard gets messy, I decided to assign myself a cost for this embarrassment, $1 per task that doesn't get completed in a given week. So to simplify, let's assume that all tasks that don't get done in one week will get done in the next. That is a simplifying assumption, which we can test the sensitivity of in a next step. But it's nice to start with your base case model making some simplifying assumptions. So let's put in here. I guess the first thing we want to do is calculate. So number of tasks not completed. So this is equal to the number of tasks that need to be done minus the sum of the tasks that get done on the weekday and the weekend. So in this case, there's 2. But this formula is not entirely right, because what if the kid can actually get more done than the tasks that are required? That's certainly possible, because on the extreme, he could get 6 tasks done on a typical weekday, and 12 on a weekend, 18. And in this case, I don't have 18 tasks that need to be done. So I don't want to let this go below 0. To be negative, that doesn't make sense. So if it were negative, what that means is he got all the tasks done. So I'm going to say, I'll say this will be the it'll be the max. If I say it's the max of this value, or 0, what's going to happen is that should more tasks get done than since if the kid could do more tasks than there are that need to be done, say the kid here can do 6. That means that he could get 13 done in this week if I had them. Now, instead of this saying -1, 12 minus the sum of 6 and 7, 12 minus 13, instead of saying -1, it's going to assign 0. There's no tasks that did not get completed. And therefore, if I wanted to calculate the cost of undone tasks, my embarrassment, so cost per task that is not completed in a week, that's $1. I'm going to type in 1, and since this is the first time we have a dollar amount, I'm going to format the cell to remind myself that this is a dollar. Currency, 2 decimal points. Okay, so total. Okay, now there's another, before I can calculate, I started to calculate the total cost, but I don't want to go there yet because the first thing I want to do is, well, make sure that I've got all the components of cost in here. I'm missing one thing. I'm missing this notion of quality. So I've offered to pay the kid $2 per task if he gets all the tasks done and does them well. So we can determine whether the kid gets all the tasks done. That's it, going to happen if this number is 0. But whether they're done well is not yet built into the spreadsheet. So are all tasks done well? I'll say 1, okay, well, question mark. And then this, the way I talked about this in the slides, I said it will either take on a value of 1 or 2. This is maybe not the best way to operationalize this, but it's what I said before, so I'll stick with it. I'll say, and my note here is 1 if yes, 2 if no. Okay,